Imagine you are on a flight, and you hear that there is a technical issue with the aircraft. For most people, that sounds serious, maybe even scary. But here is something most passengers don't realize. What sounds like a problem is often just a system doing exactly what it was designed to do. In aviation, engineers fully expect that parts of an aircraft will fail at some point. Instead of trying to make everything perfect forever, they design aircraft to handle those failures safely. This is the real reason why complete system failure is extremely rare, and why flying is one of the safest ways to travel today. The main reason aircraft systems almost never fail completely comes down to one simple idea: redundancy. In basic terms, redundancy means having backups. But in aviation, it is not just one backup. It is often 2, 3, or even more systems ready to take over instantly. Think of it like this. Instead of relying on one light bulb in a room, you have multiple lights connected to different power sources. If one goes out, the room is still lit. Aircraft work in a very similar way. Critical systems, such as electrical power, navigation, and flight controls, are never dependent on a single source. This means that even if one part stops working, the aircraft continues to operate without interruption. Let's make this more real with an example. Aircraft need electricity to power important systems like instruments, communication, and controls. But instead of having just one power source, aircraft usually have multiple generators connected to the engines, an auxiliary power unit, and backup batteries. If one generator fails, another one immediately takes over, often without anyone even noticing. The same idea applies to flight controls, which pilots use to steer the aircraft. These systems are supported by multiple hydraulic systems. If one hydraulic system fails, the others continue to function, allowing the aircraft to remain fully controllable. So even when something stops working, the aircraft still has other systems ready to keep everything running smoothly. Now, you might wonder, what if more than one system has a problem? This is where aviation design becomes even more impressive. Systems are not only duplicated, but they are also separated and designed differently. This means a single issue is very unlikely to affect all systems at once. For example, backup systems may be powered differently or placed in different parts of the aircraft. This reduces the chance of one failure causing a chain reaction. Even in unusual situations, aircraft are designed to continue operating safely, giving pilots time to respond and make decisions calmly rather than dealing with sudden emergencies. Another important idea in aviation is something called fail-safe design. This might sound technical, but it is actually very simple. It means that if something does fail, it will fail in a way that keeps the aircraft safe. For example, some systems are designed to move into a safe position if they lose power. Others are built to keep working at a reduced level instead of stopping completely. Even the structure of the aircraft is designed this way. Instead of breaking suddenly, parts of the aircraft are built to show signs of wear over time. This allows maintenance teams to find and fix problems before they become serious, so failure is not sudden or dangerous, it is controlled and predictable. Aircraft safety is not based on just one idea like redundancy or fail-safe design. It is built on multiple layers of protection working together at the same time. First, systems are designed to prevent problems from happening. Then, sensors and monitoring systems detect any unusual behavior. If something is detected, alerts are generated so pilots and technicians can respond. At the same time, backup systems are ready to take over instantly. Even in the worst-case situation, there are still additional safeguards in place to protect the aircraft. You can think of this like multiple safety nets. Even if one fails, there are others ready to catch the problem. For an aircraft to completely lose a critical system, several independent systems would have to fail at the same time. This is extremely unlikely because these systems are designed to be separate, independent, and reliable. They do not share the same weaknesses, and they are tested under very strict conditions. Aviation regulations also require systems to meet high safety standards before they are approved. All of this means that total system failure is not just rare, it is something engineers work very hard to prevent at every level of design and operation. When you put all of this together, backup systems, fail-safe design, and multiple layers of protection, you start to see why aviation is considered one of the safest industries in the world. It is not because failures never happen, but because aircraft are designed to handle those failures safely. Every part of the system is built with the idea that something could go wrong, and there is always a plan in place when it does. This level of preparation is what keeps flights safe every single day, all around the world. So the next time you hear about a system issue on an aircraft, remember that it is not a sign of danger, but a sign that the system is working exactly as it should. Aircraft are never relying on just one system. There is always a backup, and another layer behind it, all designed to keep everything under control. That is not luck, that is engineering at its best. If you want to learn more about how aircraft really work and understand aviation beyond the basics, make sure to subscribe to Deep Blue Avionics. We break down complex aviation topics into simple, real-world explanations so you can truly understand what happens behind the scenes.